Hello. What you are about to see is broadcast quality TV. What you're about to hear is high fidelity stereophonic sound. See it? Hear it? All made possible through Pioneer Laserdisc, technology perfected to an art form, as is the new Pioneer Projection TV, which in the next little while will take you to places you've never been and show you things you've never seen. To Japan, where Pioneer got its start over 40 years ago and has since been at the forefront, developing many of the technological breakthroughs that make hi-fi everything it is today. And as Pioneer emerged, becoming a world leader in the industry, it set standards that others could only shoot for. Standards that have raised the level of performance across all price ranges, putting quality hi-fi within reach of nearly everybody. Much of Pioneer's success in producing audiophile quality at low cost is due to advanced technology in both manufacturing and research. 3D laser holographic analysis to pinpoint distortions that most manufacturers aren't even aware of. Beyond computer technology to microcomputer technology, for accuracy and reliability unheard of even a few short years ago. Speakers with incredibly low distortion, tuners that don't drift, amps free of switching distortion, tape decks with 3 direct drive motors, turntables with inaudible wow and flutter, receivers with all electronic controls. All of this in Pioneer's all-new line of high-performance equipment, more precise, advanced, and reliable than anything ever before available. And although these products are brought to you through space-age technology, we at Pioneer know that space people do not use them. Humans do. Who are you?
I'm a human being. And you have a little more proving to do.
Where should I start?
Well, try me on receivers.
Okay so far?
Hey!
Turn it on.
That is good sound. But where are all the knobs and dials?
They're inhuman. Try the volume control.
That is more like it.
Volume, balance, muting, all together.
Digital readouts, right?
And digital accuracy.
I don't need a head amp?
Nope. That alone can save you over $100.
Hey, what's going on?
You've activated the auto station scan, so you're previewing all of the strong stations in your area.
Those lights. I think they're trying to tell me something.
They're telling you everything. Pioneer not only builds it all in, Pioneer helps you get it all out. See? This light tells you the phono section's on. This light gives you a power reading. Go ahead, turn it up. Now listen.
That is clean sound.
It should be. Who else has Pioneer's non-switching power amp and ID MOSFETs?
MOSFETs? Non-switching?
Don Herbert can explain it better than I can. Better than anyone, actually.
Hello, I'm Don Herbert. You may remember me as Mr. Wizard. I'll be giving you the technical background that helped make possible some of the new Pioneer developments, such as the non-switching power amplifier and the ID MOSFETs. But before we get started, to make sure we're all on the same wavelength, so to speak, let's look at the important sections of a receiver. The first stage of the tuning section picks up all the signals received by the antenna, which are extremely weak, and amplifies them enough for later processing. The next section selects only the signal coming from the desired station and eliminates all the others. Then the selected radio signal is converted into an audio signal, and the audio signal is made strong enough to drive the speakers that reproduce the sounds represented by the original radio signal picked up by the antenna. Well, that's what goes on inside of a radio receiver. Back here at the first stage of the tuning section, the extremely weak signals have to be amplified without distortion. But here's what can happen. Let this oscilloscope trace represent the signal coming from a strong station. and this trace the signal coming from a weak station. Now, they're not separate like this as they come into the first stage of the receiver. They're combined among the jumble of frequencies and added together so that the total signal approaches the limit of the capacity of the first stage to handle them, primarily because of the ordinary transistors used in the first stage. If you try to boost the signals stronger like that in order to get better reception of the weak station, the signals can be amplified beyond the limit of the equipment to handle them. The peaks are rounded off at the upper and lower limits due to the overloading of the transistors. As you know, this is distortion. Pioneer's ID MOSFET transistors, in effect, can expand both the upper and lower limits and can amplify the combination of strong and weak signals without overloading and thus producing distortion. A greater range of signal strength can be amplified, which means you can tune in on a weak station in the presence of a strong station without the strong one interfering with the weak one. All this is made possible in the first stage, the front end of the tuner, because of the superior signal handling characteristics of Pioneer's exclusive ID MOSFET transistor. Now, Pioneer has also improved the way the final audio signal is processed before it goes to your speaker. The signal entering the last stage of the amplifier is the weak audio signal that has to be amplified enough to drive the speakers. Now, the circuit uses the weak audio signal as a control voltage to produce a much stronger signal at the output of the transistor. This transistor, the top one, amplifies only the top half of the signal, while the other transistor amplifies the bottom half. The upper half of the strong signal provides a voltage to move the speaker cone out, in effect giving it a push. The lower half of the signal does the reverse. It produces a negative voltage that drives the speaker cone back, giving it a pull. This push-pull circuit was a major improvement way back in the early days of vacuum tubes and has been used ever since, but now with much more sophisticated circuitry using transistors. But there's a problem with it. At the point where one transistor switches off and the other one switches on, that's the trouble spot. If you looked at that spot greatly magnified, you'd see that the crossover from one transistor to the other is not smooth. There's a slight distortion added to the signal. Now, the conventional solution to the problem of transistor switching supplies an idling current to both transistors so that neither of them ever completely shut off. Engineers call it a small bias current, but I like to think of it as an idling current because it functions something like the idle setting on your car's engine. Instead of the engine being turned off every time you stop your car, it idles at a very low speed. And that's the function of the bias current in an ordinary push-pull circuit. Pioneer has gone a step further by producing a sophisticated control circuit that supplies continuously variable bias. Each transistor, when not in use, is fed a bias current that's directly proportional to the strength of the music signal. So when its turn comes in the push-pull cycle, that transistor is more than ready to go without any switching distortion. Only Pioneer has this patented non-switching push-pull circuit that totally eliminates transistor switching distortion.
You know what impresses me most about your receivers?
What?
Someone thought of me. We human beings need every break we can get, you know.
Well, at Pioneer, you're what it's all about. We even call it human engineering. Find out what's important to people and provide it.
You mean like your amps, right?
You got it. Non-switching, of course.
Of course.
Along with mode monitor light, power level reading, automatic subsonic filter light, push-button cartridge load selection, and for real sensitive ears, line straight bypass.
Line straight bypass? It sounds like Don Herbert time again.
No, I can handle it. It means that you can bypass tone, balance, and mode controls for a purer music signal.
How's that happen?
The sound signal goes through fewer circuits and travels a shorter distance.
New subject. I have this cousin who wants to know about DC servo.
DC servo. We have it. Right, Don?
Pioneer has DC servo. As you know, a speaker system converts an electrical signal into sound. Because the electrical signal is AC and contains no DC, and since DC can actually damage a speaker system, amplifiers are designed to pass as little DC as possible to the speakers. Now here's a simple diagram of the kind of circuitry used in most amplifiers to reduce DC in the output. First, a DC blocking capacitor is used to filter any DC from the input before it enters the amplifier. Then a DC balance adjustment is usually included to compensate for any DC that may originate in the amplifier. But there are problems with this conventional method. The DC blocking capacitor, usually the only capacitor in the signal path, reduces the purity by adding a bit of distortion. And the accuracy of the DC balance adjustment can drift with age and temperature. Here's Pioneer's new circuit. The blocking capacitor has been removed from the signal path, so the distortion due to such a capacitor is eliminated. The DC balance adjustment has also been removed. In their place, Pioneer has provided a DC servo circuit which is not in the signal path. Any DC in the input or developed within the amplifier itself ends up as part of the output. The DC servo circuit, using a new principle, senses any DC in the output and generates a correcting signal that reduces the value of the DC component by a factor of 3,000, virtually eliminating it. Not only does the DC servo circuit challenge the accuracy of a manually set balance adjustment, the DC servo is automatic and is immune to drift over time and changes in temperature. The result? Virtual elimination of the DC in the output and an unobstructed signal path for cleaner, purer sound for the life of the amplifier.
And now, the one thing that can top a Pioneer amp, a Pioneer tuner.
Corny, but very nice.
Some of the best specs ever achieved in a tuner, plus some features never before available. Turn it on.
Talking lights, right?
Uh-huh. Here's your digital frequency readout. The multipath light tells you when to reorient the antenna. 12-station memory presets, stereo indicator, signal strength.
And here we have...
Auto and manual tuning, mode controls, wideband, narrowband, tape recording level check.
Digital synthesized tuning?
Of course, along with push-pull front end and digital detector.
Time for Don Herbert.
Another important part of a tuner's design is its ability to amplify high-level signals directly from the antenna without front-end overload. And front-end overload is to be avoided because it causes other circuits in the tuner to distort. And in the end, the station you're trying to listen to won't sound as good as it should. Pioneer's ID MOSFET transistors exhibit a significantly higher overload capacity than any other similar device. But Pioneer has gone a step further in preventing front-end overload. You see, nearly all power amplifiers and many integrated circuits use transistors in a push-pull configuration when high power or high voltage must be developed. Remember Pioneer's non-switching power amp push-pull design and how half of it pushed the speaker cone in one direction and half pulled the cone back? Push-pull circuits using two transistors working together can provide higher output than one transistor alone. So to further increase the overload level in their ID MOSFET front end, Pioneer's engineers designed a push-pull circuit for their tuner using two ID MOSFETs. Now the level is doubled before overload can occur. The result is a tuner that can be used with a powerful high-gain antenna even in areas with crowded airwaves. Digital is a new way of handling information that everybody's talking about. You see, a radio signal, including the audio information, varies continuously because it corresponds directly to all the frequencies and amplitudes of the original music or other sound. It's an analog representation of the original signal. Now here's the problem. When noise is introduced to an analog signal, the noise becomes part of the total signal and is very difficult to remove. Pioneer solved the noise problem with a digital detector. The music, while it's still a radio signal, is converted into a code that's a series of pulses that are all the same size. But the space between the pulses varies according to the information. As long as the space between the pulses can still be distinguished, any noise that becomes a part of the signal can easily be removed. This is because the noise can be easily filtered from the coded signal without removing any of the information. Here, let me show you. With the tone generator, here's the Morse code for the letter P that represents the encoded music information. Now I'll add noise. You can barely distinguish the pure wave, but in spite of the noise, the information, the did-da-da-dit, is still recognizable. You see, the digital signal can be processed in the conversion box without processing the noise. That's Pioneer's digital detector. It provides an audio signal in Pioneer's top tuner that faithfully follows the original broadcast without adding noise.
Oh, that's terrific, but how does it sound?
Try it. Pioneer's goal in tuners is to bring you the same clean music that the disc jockeys hear in their studios.
I think you did it.
You seem different.
I'm a human being. I'm also the cousin. Where do I get the specs on all this beautiful stuff?
It's all on the disc now playing and indexed on the disc cover. Care to see side 2? Will somebody out there please flip us over? Found the tape deck, huh?
Clear as a bell. Give me some details.
Well, let's start with the microprocessor control.
Remember, I'm not a space person.
Relax. You're about to encounter the first high-fidelity microprocessor designed for human beings.
What exactly does that mean?
It means that through its microprocessor control, Pioneer has given you the industry's first precise index scan. Now you can find and preview the first 5 seconds of every piece of music. Here's another Pioneer first, a remaining time counter. Combined with Pioneer's blank search, it not only stops where there's blank tape, it tells you exactly how much recording time is left on the tape. And of course, skip reverse, music repeat, and auto reverse.
What you're really saying is all play and no work.
I wish I had said that.
Bias level and equalization, I see.
All automatic, to give you the maximum performance from each tape.
Give me a hint at the price.
You can pay twice as much for some tape decks and not get all these features.
And all that great sound? How do you do it?
And welcome Don Herbert.
Here's an illustration of a conventional cassette deck head frequency response. The top line is the output, and the bottom line is the noise. Boosting treble to the proper level also increases the noise. This is heard as tape hiss and is a major concern when buying a high-quality tape deck. Now, you know that a transformer is made up of several thin metal plates with insulation in between, because magnetism produced in metal also produces eddy currents or unwanted electrical disturbance. Musical signals, for example, going through a tape head create eddy currents in the same way, which interfere with high frequencies, resulting in the conventional graph over there of a cassette deck head frequency response. Now, electrical measurements show that the thinner the metal plates, the less eddy currents. So the thinner the plates that make up the tape head, the better the high frequency response. Sendust is an excellent head plate material because it resists wear and can produce strong magnetic fields without distortion due to overload. Now, ordinary Sendust heads are made up of 2 or at the most 3 layers. Only Pioneer's advanced manufacturing technique have produced Sendust in ribbon form. Pioneer uses 11 layers in each channel in making an audio cassette head. So when musical signals go through a ribbon Sendust head, they create eddy currents that are so weak they don't interfere with the high frequencies. You'll note that there's almost no boost necessary in the high end. Therefore, there's significantly less of an increase in noise level and much less tape hiss. What this means to you is a much cleaner, clearer high end and better total sound. Now let's look at Pioneer's new 3DD tape drive system. It makes possible most of the functions you've just seen. First, simply adding a microprocessor to an ordinary cassette deck will not provide the precise control over the cassette tape that's required for the type of sophisticated features like the ones on Pioneer's new decks. So Pioneer developed a transport mechanism with an individual direct drive motor for each spindle, and a direct drive motor, a third one, for the leading capstan. When given the complex simultaneous commands generated by the microprocessor, the 3-direct drive, 3DD transport, gives precise control over the tape's movement. Now here's what happens when you use one of the more complex features like index scan. The take-up motor pulls the tape forward at high speed, while the supply motor provides just enough back tension to keep the tape taut as it passes over the head. The playhead reproduces the recorded program as the tape goes by at high speed. Now, simultaneously, the microprocessor monitors the output and looks for a blank section of tape between music sections. I'll use the leader to represent the blank and the tape itself to represent the music. When it finds a blank and then the beginning of the music section, it signals the motors to stop and back up to the very beginning of the music, and then normal play gives you the first 5 seconds of music. Then the entire cycle is repeated. Fast forward engages, and the process of previewing the first 5 seconds of every music section on the tape continues. This precise interaction between the highly responsive 3DD motor transport system and the microprocessor makes possible complex functions like index scan, skip reverse, and music repeat. Advanced microprocessor technology and advanced motor technology are combined in the Pioneer cassette deck to give you a unique set of human engineering features.
I didn't expect you to lead with your woofer.
I led with my woofer because it's polymer graphite.
Well, what about your tweeter?
That's no tweeter, that's a super tweeter. HPM, a Pioneer exclusive.
You better go into polymer graphite and HPM a little more.
I've just cut out 2 speaker cones, one of paper and the other of polymer graphite. Now, to reproduce sounds accurately, a speaker cone must be low in mass. Both the paper and the polymer graphite are low in mass. Then, it should have no sound of its own. In other words, it must be non-resonant. The paper is pretty good, but the polymer graphite is much better. And finally, it must be highly rigid to produce low distortion at high sound pressure levels. Here's a test for rigidity. These are 10-pound barbell weights. Now, 20 pounds. Here comes 30. 30 on the polymer graphite. 40 on the polymer graphite. 50 on the polymer graphite. In spite of all that pressure, the polymer graphite speaker cone remains structurally sound. To the listener, a polymer graphite speaker cone means low distortion with an extended high-end frequency response, but it adds virtually no sound of its own. It speaks only when spoken to. Here's another Pioneer Plus in sound, the HPM Super Tweeter. Now, as you know, ordinary speakers use the principle of electromagnetism to move a cone in and out to generate sound waves in a forward direction. A larger cone reproduces the lower frequencies, and a smaller cone reproduces the higher frequencies. At very high frequencies, the sound waves are only about an inch or so in length, and the cone to generate those sounds is also on the order of an inch or so. While such a tiny speaker can generate the highs, they're very directional, going out more or less in a straight line directly out from the speakers. You can hear them best only when you sit directly in front of the speakers. but the highs should cover a broader area so listeners anywhere can hear them. Pioneer solved the problem in a unique way. Instead of electromagnetism, Pioneer uses the piezoelectric effect. Remember the ceramic phono pickup? The vibrations of the stylus put pressure on the ceramic and changed its shape slightly, and that's what produced a voltage. Now, the opposite is also true. When you apply a voltage to a piezoelectric material, it changes shape. Certain crystals do that, and so does this sheet of HPM film. When it receives an alternating voltage, it gets longer and shorter. When wrapped around this foam cylinder, it produces vibrations that spread out in all directions. Pioneer cut out a section of the sheet and placed it here in this special frame, and then added an acoustic lens to further disperse the sound pattern. The result? A super tweeter with an extremely flat response, not only in the center, but elsewhere as well, so you can hear the very high frequencies throughout the room, no matter where you sit. Only Pioneer has this super tweeter using the piezoelectric principle for broad dispersion of very high frequencies.
Mind if I have a look?
No. In fact, I was going to suggest it, because there's a very critical thing to remember. It's not enough to make the speaker elements out of ideal materials. You also have to make them work perfectly together. And that requires such design precision that Pioneer entrusts it only to a computer.
What you're telling me is that you know what a speaker should be, and you know how to build them.
Once again, I wish I had said that. And now will you believe that model for model, Pioneer's distortion is measurably lower than anybody's in the industry?
I believe.
And now for the place where it all begins.
You mean the turntables?
I mean turntables the likes of which you've never seen.
You mean heard?
I mean, turn it on.
Not so fast. This is beautiful without sound.
Notice the tone arm? There's some real beauty.
It's straight. So are a lot of others.
It's polymer graphite. None of the others are that.
It's straight line tracking. Are you telling me that's different too?
The way Pioneer does it, yes.
I think we need you, Don.
One of the most important aspects of a turntable is the tracking of the stylus across the surface of the record. Ideally, the tone arm should be at a right angle to each groove. Now, this can be accomplished when the whole arm, from the stylus to the pivot point, move at a right angle to each groove. Other straight-line tracking turntables move their tone arms with a worm gear or pulleys and belts that can be noisy and wear over time. Pioneer has eliminated such mechanical couplings by using magnetic repulsion to move their linear tone arm. Did you notice how smooth that action was? You see, a fixed magnet is in the base of the tone arm, and electromagnetic coils are in the track. The coils are energized by a small electric current that produces magnetic repulsion along the track. To position the tone arm at a right angle to each groove, Pioneer has a circuit in the base that senses the slightest stress and sends a current to the track to continually adjust the position of the bass, sending it smoothly across the record. Now, this record has a special track that covers the standard LP record surface in about 30 seconds. Yet, the tone arm was able to track even this exaggerated movement. With the linear tone arm, the stylus is always positioned in perfect alignment with the sides of the groove to provide essentially zero tracking distortion. Only Pioneer makes this precision, electromagnetic, linear motor-driven tone arm that assures accurate tracking and extremely quiet operation. And now for the tone arm itself, since it's unique to Pioneer. Polymer graphite is a low-mass, rigid material used in Pioneer's HPM speakers. It's also the material used by Pioneer in their new tone arms. Now, here are two tone arms suspended from threads, an ordinary aluminum one and an identical one coated with polymer graphite. I'm going to tap each one. Listen. Did you hear the ringing of the aluminum one and the deadness of the polymer graphite? Obviously, any vibration of the tone arm will produce distortion in the music you will eventually hear. Again, the plain one and then the polymer graphite. The ringing of the aluminum shows that it vibrates easily, but the polymer graphite absorbs vibrations, so it can't ring. almost like tapping a piece of putty. The polymer graphite tone arm immediately absorbs and terminates vibrations. Sounds in the room, for example, are coming from your speaker. The only vibrations that reach the cartridge come from the stylus and that are picked up from the record groove. And that means the signal is virtually free from distortion caused by tone arm resonance.
Now are you ready to play it? Don't. It's my turn to explain something. Those buttons and switches are electronic soft touch, so there's no jolt turning them on and off. The suspension is coaxial. Drop the dust cover. Go ahead, drop it. See? Nothing happened. Now thump it with your finger. See? Nothing happened. That's Pioneer coaxial suspension. Now for Pioneer's stable hanging rotor. Pick up the pencil. Hold it at the bottom where most turntable motors are placed. Now imagine the platters on top. See how easily it tips and sways? Now hold it near the top. That's where Pioneer's motor is placed. Less sway, less wobble, less wow, less flutter. In other words, Pioneer turntables add less sound to the sound.
Less sound to the sound. That's very good.
Here's another. When you care enough to hear the very best. Here. Catch.
Pioneer has a new cartridge?
Look closely. It's a moving coil cartridge. Audiophile quality.
Do I need a head amp?
Not if you have the Pioneer amp or receiver I showed your cousin.
High performance?
High performance, lifelike sound, and it's low mass. It's only 4 grams.
I stayed with you on everything but the mass.
Low mass is no mystery. Here's the way Pioneer's new moving coil cartridge, with low mass, is better able to create lifelike musical signals than the more massive moving magnet type cartridge. The end of the hacksaw blade swings back and forth at high frequency. Now I'm going to stick a ball of modeling clay on the end to represent the mass of a magnet. As I vibrate the blade, you can see that the ball moves slowly. Now you'll note it's not the weight of the clay that's dampening the vibration. The clay is supported against the pull of gravity by the blade. It's the mass of the clay that dampens the vibration. You see, scientists define mass in terms of inertia, the tendency of a body at rest to remain at rest. The greater the mass of an object, the more inertia it has. Now I'll put on a smaller clay ball to represent the mass of a coil. The coil, with less mass and therefore less inertia, can better follow the vibrations in the record groove, producing an electrical signal that more accurately represents the music signal on the record. After seeing the damping effect of the large ball of clay, typical of the moving magnet cartridge, it follows that the lower mass of the coil in Pioneer's moving coil cartridge more easily responds to the vibration of the stylus, thus providing higher fidelity and a more lifelike musical signal. Now, while a smaller mass, like this smaller ball of clay, can follow the vibrations of the stylus more easily, there's more to Pioneer's cartridge than just low moving mass. Now I'm vibrating the ball at the end of the hacksaw blade at its natural frequency. It has a natural resonant frequency that can interfere at times with the vibration of the stylus. Pioneer solved the problem with a new material for the stylus, a special metal called beryllium. It's very rigid. We'll let this other hacksaw blade represent Pioneer's new stylus. I'll start them both at the same time. Watch. See how quickly that one stops oscillating while the first one's still going? Pioneer's beryllium stylus is tapered, and the combination of material and shape is unusually free from natural vibrations in the audio range and responds more closely to the vibrations in the groove of the record to produce a clean, clear signal.
Thanks, Don. You're a wizard. Do you know what strikes me most about Pioneer?
Be kind.
Be kind. I could be effusive.
Be effusive.
Well, I think it's tremendous, making this fantastic line of equipment and then making it possible for me to get everything out of it. And no matter what I choose, the quality is all there. And I can build any kind of system I want because everything works together without compromise.
Ever thought of going into sales?
Oh, it would be easy to sell Pioneer. Do you have the specs?
They're all right here on the Laserdisc. Thanks for dropping by.
You're leaving me here? With all this?